Welcome, everyone. This is Mike Clark. We're going to launch a poll while we're letting everyone come into the room here. Welcome to today's session. Please answer the poll. Thank you. Hi, welcome. Today's session is the 6 key considerations when selecting a cloud data integration solution. Our speaker today is Mark Vanderweel. He is the Chief Technology Officer of HVR Software. And today your moderator is myself, Mike Clark. Thank you all for coming. Mark, next slide, please. Yeah, so a little bit of housekeeping. So this is an online presentation, so there's no audio, but if you have any questions, please feel free to enter a question into the question window, and we will respond to all questions and process all questions at the end of the session. But please submit those questions as soon as you can. Thank you. And so today, our sponsor is HVR, and we do appreciate them. We'd like to thank them for presenting sponsors and their continued support. If you'd like to learn more about the HVR software and receive information and how they can help you, please visit hvrsoftware.com. And so this is today's session is the Database Administration Virtual Chapter. We are a subgroup of PASS, and the PASS Summit 2020 is going to be this fall in Houston. And so right now there's a call for volunteers. PASS is a volunteer-run organization, and so it's run completely by volunteers. If you want to be involved in either program selection or anything involved with PASS this year in Houston, please scan the QR code on the screen, and all of these slides will be online later this week. You can scan that QR code and offer to help make PASS an even better experience for those coming. Also part of, so PASS has many different venues to keep connected, and so we keep learning all year long. So visit pass.org and check out all the free educational opportunities that are available. There are an array of different groups, so we can connect, share, and learn as a community. One of the other things that PASS has is a SQL Saturday, and so those are around the world in many different time zones. They're free day training events for professionals who use the Microsoft Data Platform. You'll find it's a great way to spend a Saturday. These local community events, they offer content across data management, cloud, hybrid architecture, analytics, business intelligence, AI, and many more things. For more information, go to sqlsaturday.com and click on the upcoming events, and you can register. You can actually present here. It's a great place to expand your exposure. So feel free to participate in SQL Saturdays. They are great events. And with that, I'd like to come into today's session. This session is presented by Mark Vanderweel today. He has over 15 years of hands-on experience with multiple relational databases, data warehouse and data replication technologies, including SQL Server. In his current role as technical lead for the independent database replication company, HVR, Mark comes across many SQL Server deployments, on-prem and Azure cloud. Mark holds a business administration degrees from Eindhoven University of Technology. And without any further ado, here is Mark to talk about the 6 key considerations when selecting a cloud data integration solution. Thank you, Mark.
And thank you, Mike. So welcome everyone. Good morning, good afternoon, maybe even good evening, depending on where you're dialing in from. So today we're going to talk about 6 key considerations for choosing a cloud data integration solution. So what I first want to do is introduce the topic here, because what we're seeing is there's a renewed focus on data integration. Of course, the cloud has become very popular for almost every organization. And what we're seeing as we work with our clients, that a lot of the organizations look at expanding their data center into the cloud and start with analytical solutions built in the cloud. We see a lot of data warehouses being built in the cloud. Of course, in the Azure cloud, we see a lot of the Microsoft Synapse adoption. We see Azure SQL. We see folk running managed instances of SQL Server. But we also see third-party products running in Azure, like a Snowflake, for example, as a data platform. We see organizations building out data lakes in ADLS. We see some folk using blob storage. So we see a lot of adoption of cloud technologies, specifically around analytics. And then obviously there is then a need to feed data into those kinds of systems. And that's what we'll focus on today, with the renewed focus on data integration. In this slide, we're trying to depict the variety of sources that are feeding into those systems. So if we start on the top left, we see like web feeds, logs from web servers, maybe JSON files, maybe CSV input feeding into the data lake. Organizations will have Internet of Things kind of sources, right? Machine generated data. Maybe you're a car manufacturer and you have your machines, your cars running on the highways, generating all these events, and you want to store those into your data lake, into your data warehouse for analysis. It could be sensor data, it could be social media information that you're using to gain competitive advantages over in your market. It could be streaming data feeding into the data warehouse. But then what we also still see is a lot of the traditional databases, the relational databases, of course, a lot of systems running SQL Server, also lots of systems running other traditional relational databases. And then also, let's not forget about the applications storing some of the core data that we use to run our organizations, right? The ERP systems and CRM systems and the supply chain management systems, all kinds of prepackaged applications that run on relational database technology, from which we want the data to be included in our data warehouses and data lakes. So again, this development, organizations adopting the cloud, organizations building data warehouses and data lakes in the cloud, is generating a renewed focus on data integration. So speaking of data integration, what are some of the challenges that you have to overcome? Right, so the end users that maybe you as a data professional are dealing with, they may be asking you for real-time data availability, right? So today's world, we need up-to-date information as close to real-time as possible in order to gain that extra competitive advantage, or maybe to reduce the extra risk that comes in with the delay of getting data or getting access to data, or maybe it's a means of reducing the cost, right? Real-time data availability is something the business users are asking for. Of course, we're all worried about security, right? Like almost every organization today is comes across security events. We read about security or data breaches in the online media almost on a daily basis. Security is a really big thing, and of course, if we take data, as happens so often in today's day and age, out of on-premises systems and deploy it into the cloud, security is a topic that we really need to take front and center, because we're out there in the public, on the public internet with our data. We also see lots of organizations with cloud sources as well. So data already resides in the cloud, and maybe it moves across the boundary from one cloud to the other, or maybe it doesn't. But anyway, security is an important topic because we are accessing the data using public internet infrastructure. Transferring data over a wide area network, that commonly happens, or that always happens, I would say, if we go from an on-premises data center into a cloud-hosted environment. Transferring data over a wide area network, of course, depending on the data volume, can introduce bottlenecks. And what are you going to do to avoid them? What are you going to do in line with the first requirement there, real-time data availability? How are you going to manage that? How are you dealing with large volumes of data feeding across the wire, right? I showed that initial diagram showing the variety of data sources and all of the data that nowadays gets pulled into data lakes and into data warehouses. We're dealing potentially with machine-generated data that can generate some massive volumes. How can we deal with that? And then the other aspect of it is many destination technologies, right? So in the cloud, one of the benefits that we have is access to scalable environments, essentially at almost literally the swipe of a credit card. We can start using technologies, using a pay-as-you-go model. They are built to be scalable in the cloud. And we can explore some of these technologies to see if they make sense, because no longer, in contrast to like 10 years ago, no longer do we have to put together an infrastructure and justify a purchase to get a perpetual license for a technology. No, it's a pay-as-you-go, and it's already scalable, so we can explore some of this. But then, of course, you're going to be naturally dealing with more destination technologies, because maybe you're going to try, let's say, the Azure Event Hub, and you're going to try the Synapse, and you're going to try an Azure SQL, and maybe you continue using them, and maybe you don't. So, but from a data integration perspective, you need to get the data to the technology that you're going to use for the goal you're trying to achieve, or the goal that the business wants you to achieve. So bit of the terminology, right? And when we talk about data integration and we think about, well, what might be the right approach, HVR, we're in the data replication space. So I can certainly promote my opinion, but I do want to give like an honest overview of what's out there, what's available, and then depending on your use case, you can decide what works best for you, right? So the term ETL, extract, transform, load, or ELT, extract, load, transform, those terms are commonly used in the industry. For those kinds of scenarios, generally the data integration is not in real time. Volumes can be very large, but for the duration of the extract, the impact on the data source can be very high. It's a pool model, but then we have very rich transformation capability, right? Contrast that to like a data virtualization, where the access to the data is in real time, but realistically, you'll be accessing relatively small volumes, right? And then you can look at some of the other attributes of data virtualization from the different angles that I put onto this slide, right? So we can look through streaming. We can then look at replication, right? So replication, and specifically log-based data replication, so where the data replication technology accesses the transaction logs to retrieve the change data, can be in real time, right, or close to real time. volumes can actually be really large. We have customers who, on occasion, generate multiple hundreds of gigabytes of change data on a single system in 1 hour, and they can still do real-time data extraction of that with very limited, if not no impact on the data source. It is then from the perspective of the change data capture, it's going to be a push model. But then the disadvantage or a potential disadvantage could be that there is low transformation capability. Now, the way some of our customers deal with this is that they'll replicate the data into a destination system and then run incremental small ELT cycles on top of that. But it's certainly to be noted that as the data arrives in the destination, it would have gone through limited transformations. And then last on the list, message-oriented data movement. For some time, that was a popular data integration technique, but it's got its limitations from a limited volume perspective, and then also from a limited transformation perspective. Of course, it can be augmented. It can become a platform to build on top of, just like data replication can be. But just out of the gate, message-oriented data movement provides also a low transformation capability. So again, what is the right approach? It comes back to what are your requirements? What are you looking for? And well, what is your situation, right? What industry are you in, and et cetera, et cetera. So let's talk about some of the 6 key considerations that we think are important as you evaluate what is your best data integration technology for the cloud. So 6 factors, right? Key considerations, and I'll go into detail on every one of those. Is the connectivity aspect, right? Like, to what extent do you or do you not need heterogeneity for the technology you're going to use? We're looking at a couple of angles from a scalability perspective. What's the performance impact, right? Both on the source and the destination side. What's the effort from an implementation perspective? How about data quality? What are your considerations there? And then, as I'd mentioned before, we always need to worry about security because we are looking at cloud systems. We are using internet connectivity to access the data, to potentially move data across the wire between sources and destinations. So let's talk about connectivity and heterogeneity. So there are many types of sources, right? Like, even if you think about relational database sources, and we see this across the organizations that we work with, there's many different types of sources, right? There's, of course, SQL Server, but there's also Oracle out there. There's Postgres, there's DB2, there's MySQL, there's a multitude of relational databases alone that are out there that you'd want to support. There's maybe some non-relational database sources that you want to extract from as well, or there's logs that you receive that you want to deal with, and how are you going to process that data as you implement your data integration scenarios for the cloud. There's multiple types of targets, right? Like I mentioned already, that in the cloud, we have access to scalable data processing technology at the swipe of a credit card. And we could explore some of these technologies. So does the technology you're exploring, does it support some of the types of destinations that you'd like to explore? And then as cool as the Azure cloud is, the reality is there's more than one cloud, right? There's obviously, aside from Azure, there's the AWS cloud, right? Amazon. There's the Google Cloud Platform that's generating a lot of excitement. But then there's a lot of cloud providers beyond that as well. And maybe you're using some of these. Maybe you're using applications hosted in the cloud, right? Software as a service. Salesforce is an application that we at HAR use, right? But there's lots of organizations out there that use a software as a service like that. But maybe you're using other technologies and you want to integrate data from those as well. Maybe you're using Zenefits, or you're using Zendesk, or you're using Workday? Can you work with those kinds of data sources, or maybe even data destinations as well? So that you need to consider that. So one of the key considerations, or the first key consideration, is connectivity, heterogeneity. How are you going to access all those systems and deal with all those technologies? And maybe you do end up using more than one technology from a data integration perspective, but it is something to be considered. You don't necessarily want to start using a different technology for every different platform or every different cloud you're integrating with, because that becomes unmanageable in and of itself if you have multiple endpoints for your data. Second key consideration is scalability, right? Scalability, of course, has a performance aspect to it. How much data is getting generated by my primary system? And I mentioned this already. We work with organizations who generate well over 1 terabyte of change data in a day, and in some cases, even that much of change data in about an hour. Think back to some of the business requirements that your organization has, and maybe there is a need for access in real time or near real time. So can the technology you're planning to use scale to that level of performance? Now, scalability, of course, has another aspect to it, right? It's an ease of deployment. It's what kind of infrastructure, as much as we don't necessarily deal with the management of the infrastructure directly in the cloud, there's still a component to scalability from a deployment perspective out there, as well as cost, right? Like how, if a deployment gets complicated, if it is hard to put it in place, well, then that introduces extra cost, and that always needs to be part of the equation. How can you continue to manage this, right? Like, is this an environment that you can scale out by, let's say, running in a distributed environment, or is it centralized where at some point you're going to need to put an extra component side by side with the first one? And then how can you manage an environment like that when you potentially have multiple installations sitting out there, and are they consolidated in a single view, or are we looking at multiple individual units and potentially introduce a manageability challenge? Also, do we avoid bottlenecks, right? Like if there is a centralization point, is that potentially becoming a bottleneck in the very short term? Or is it, does it scale well? Does it scale out? Does it scale in the distributed environment? So all of these aspects, consider these in the context of scalability, which is our second key consideration for cloud data integration. Then think about the performance impact, right? Avoid impact on data sources as much as possible. Avoid performance impact on the destination systems as much as possible, right? Like you don't want the data integration to become the dominant resource consumer on either your source or the destination. So what is that performance impact? How can you minimize it whilst you still meet the business need? And again, the business may want close to real-time data. The business may need transformations along the way. So how can you put together an infrastructure that minimizes the performance impact on sources as well as destinations, right? On the source, of course, this may be your primary processes. So of course you don't want to impact those, because it could cost your organization dearly if and when those systems end up slowing down. But also on the destination side, right, you want to put together an infrastructure that no matter what the business case is, that the end users can utilize the system for their needs. And again, in today's world, we see a lot of analytical needs, organizations using their data for competitive advantage, minimizing risk, reducing cost, and all of those kinds of considerations. So performance impact, third key consideration. Then the fourth one, right, implementation effort, ties back a little bit to one we talked about a couple of slides ago, right? The ease of deployment, like how difficult is it to implement the technology. You're thinking about how difficult is it to build your data integration flows. Can you leave your source systems running whilst you implement this technology? You don't want to introduce an outage on your source system. You don't want to have to, let's say, duplicate all of your data unnecessarily just in order to get a stable view of the system so that you can start an initial load. So how can you align the initial data load and the incremental changes that people look at? Now, of course, there are strategies, right? When we talked about the terminology, we talked about access to like federated systems, right? Distributed access. It is a possibility, right? There's no data movement involved, but then can you meet the business needs from a volume perspective, right? Again, requirements vary from one organization to the other. And then last but certainly not least is, can you keep the systems in sync, right? Once you've implemented a technology, can you keep them in sync on an ongoing basis? In fact, is a good segue to our fifth key consideration, right? So from the fourth one being the implementation effort, fifth one is the one where we talk about data quality. So the users trust the data, right? Like if we're building an analytical environment, and let's say you're a payment processing organization, I would think that users put a lot of value into the trust of the data, right? Like payment processing, if you miss a payment or if you create the illusion that a payment might have been missed, well, that could be detrimental to the use of an analytical solution, right? Whether that analytical solution is directly accessible to the clients or whether it's an internal audience looking at it, right? Now, of course, as we build out our data integration flows, we want to make sure that we deliver quality data. So from a data engineering perspective or a data architect, that might well be you, do you trust the data, right? And do you have a means of validating whether your data is in fact in sync once the data has been delivered to the target, right? To the earlier slide is like, how do you validate that the systems are in sync? How do you make sure that the business has trustworthy data in the destination system? And then, of course, for some use cases like financial use cases, depending on the business case, there might even be regulations around the data quality that you need to fulfill in order to ensure this data quality. So fifth consideration, as you choose your cloud data integration technologies, is data quality. And then last, but by no means least, worry about security, right? Ensure that your data is secure, because by all means you want to avoid any data breaches, right? Like several years ago, somebody coined the term data is the new oil, right? And lots of organizations have embraced that concept, in that data is the new way to differentiate. Data is the new way to ensure that we maintain our competitive edge over the competition. Data is the way we reduce the risk, how we manage our costs, right? So from a security perspective, avoid introducing a weak link in your data integration pipelines. So what does that mean? That means you want to use encryption as much as possible, right? So when data moves across the wire, it should always be encrypted, and it should be a strong encryption algorithm. From a cloud destination perspective, make sure you utilize encrypted storage in the cloud as well, right? Maybe on premises, maybe on legacy systems. It was decided that at the time it was unnecessary, but I think in today's environment, it's absolutely a necessity that security should be front and center as part of your considerations when thinking about your data integration techniques for the cloud. So, a little bit about HER, right? So HER, as mentioned, we're in the world of data replication. We like to think of ourselves as real-time data integration experts. We have over 250 customers worldwide. We're represented in well over 30 countries. And across our technical field teams, we have a lot of experience. So we utilize this to deploy our software. And our software is a data replication technology that provides an end-to-end capability for data integration challenges, right? So, of course, as part of the 6 key considerations, I alluded to some of the capabilities that our technology provides, which includes the initial load capability. In fact, we can even create destination tables with our technology. We align initial loads with incremental change data capture. As part of moving data across the wire, we recommend distributed architecture where we compress and encrypt the data before it leaves the source systems. And upon delivering into the destination, that's when the data gets expanded. And we have optimizations built for a variety of technologies to ensure that we do the most optimal kind of data integration into those destinations. And all of that enables data movement in near real time. The entire infrastructure or the setup is managed through a graphical user interface, and customers use this for a lot of cloud integration scenarios. So if I may just summarize the 6 key considerations before we go over to Q&A. The checklist, right, from a key consideration perspective, what is the connectivity? What kind of data, what kind of endpoints do you want to connect up with, right? And does the technology you're considering allow for this kind of heterogeneity in your infrastructure? Think about scalability, right? In the context of wide area networks, in the context of high volume transactional systems, in the context of many data sources, maybe even some Internet of Things, machine generated data flowing into your environments. How can you deal with the scale of that data? Think about the performance impact, right? Especially on some of the primary systems that you use to run your business or run your organization. Limit that performance impact, but deal with the volume from a scalability perspective, etc. Think about the effort on the implementation side, right? And then consider data quality, right? So from a HER solution perspective, we provide the ability to compare the data at any point in time. Do you have that ability? What is your means of making sure that the end users are going to trust the data? And then again, last on the list, but by no means least, make sure that the data is secure as it moves between systems. Make sure it is secure when it arrives at the destination, which in many cases these days is a cloud-based system or a cloud-based technology. But it may also be that you're working with cloud sources, and maybe you still have an on-premises destination, or you have a mixture of those. In all cases, worry about security, because data breaches are very expensive and very unfortunate and can cause a lot of brand damage to your organization. So I hope that was interesting and useful to everybody. So with that, Mike, I wanted to see if there's any questions, and if there's a few questions we can address here as part of this broadcast.
Yes, thank you, Mark. That was a great overview of those 6 considerations. And those, as data professionals, each of those 6 considerations are stuff that we have to consider. Those are the key ones. We do have a lot of questions here, so I'm going to just start with a couple. So you mentioned a bunch about running this agent in the cloud. Can it also run on-prem? Is that option available?
Yeah, so that's a good question, right? So as part of our recommended architecture, we talk about distributed environments, and we talk about running agents in the infrastructure. And so we would absolutely recommend in an on-prem scenario to have an agent deployed in the on-premises environment. And part of that motivation is driven by efficiencies, right? I had mentioned that when technology components talk to each other, then they use always compressed data. They use encryption as configured with a specific encryption key that the customer manages. But it's also a way to have a unified access method to the destination or to the endpoint as well, right? So in the case of an on-premises environment, we see the use of agents also as a way to introduce a proxy, right? Like when we talk about data integration between on-premises and the cloud, there is often a concern raised about opening up firewalls. And certainly organizations don't like to open up firewalls into on-premises databases. And that's where the use of a proxy comes in. And in conjunction with an agent, the HAR technology certainly supports the use of a proxy that could be installed or would be installed in a so-called demilitarized zone. So an area of the data center that is exposed to the internet, but that then becomes the gateway into the on-premises data center. So from that perspective, the agent that then talks downstream through the proxy becomes a powerful component in that entire setup, because that is like it enables configurations like that I think are very beneficial and certainly can mitigate some of the concerns around the use of technologies to integrate data into the cloud.
Okay, thank you. You mentioned a few times about large transaction volumes. That always prompts questions. What does large mean? And so, what is a large transaction volume that you guys are working with, that you see rather, in for real-time data delivery?
Right. Yeah. So that's a great question, and indeed it comes up frequently. And I think part of it is because, of course, there are always a lot of dependencies from a real-time or from a change data capture perspective, I should say. So things that are or variables that are in the mix include, well, what is the transaction mix, right? Like, do we deal with fewer larger transactions, or do we deal with very many very small transactions, or is it a mixture of that? What are the table definitions that are involved in the mix of changes? Are we dealing with large objects in the database, right? Can a single transaction modify gigabytes of data in a single column value? Or are we dealing with just large volumes of, let's say, single row changes, right? So there's a lot of dependencies like that. We're dealing with wide versus narrow tables. What kind of data types generally are we dealing with beyond large objects, et cetera, et cetera. So there's a lot of dependencies there. Now, if we look at that kind of mix from a slightly higher level of abstraction, then we start looking at, well, what is the volume of transaction logs that get generated for a period of time. And then we look at peaks, right? So we certainly have customers who generate well over a terabyte of changes in a day, right? So if we look at the total amount of transaction log changes that get generated in a day, what do you back up from your SQL Server or your Oracle or your DB2 installation on a daily basis on a single system, right? So that well over a terabyte in a day. In fact, we have some customers who are generating close to a terabyte of change volume even in a single hour when they're generating at peak loads. Now, such load is generally not sustained throughout an entire day, right? Like, can you only imagine like the kind of volumes that do change when that happens? But like that happens during batch loads, right? During mass operations, when it's no longer an end user necessarily driving the change. It's a program that's introducing the change. So these are currently some of the upper level of change volumes that we see on relational databases, a terabyte, up to a terabyte in an hour, I would say, but then slightly lower from a daily volume perspective on an aggregate basis, right? So not a terabyte per hour for a 24-hour window, but rather maybe close to a terabyte is the peak, but then throughout the day, it's a few terabytes total.
I see, yeah. So from a cloud strategy in your software, do you see any differences or favor one cloud provider over another, whether it's Google Cloud, Azure, AWS, or Oracle's cloud that they're trying to get going and so forth? Do you see a difference in that, or is it all the same, or what?
Yeah, so that's a good question. I think what we see is very much a reflection of what the broader market is doing, right? Like you can get cloud, you can look up on the internet what is the distribution of cloud, of revenues or adoption of cloud providers, and what we see out there is largely in line with what we see as an overall from an overall cloud adoption perspective. So traditionally, and certainly from an early adoption perspective, we used to see a lot of AWS. More recently, we're seeing an awful lot of Azure coming up, and then in the last few months, certainly the Google Cloud Platform has shown a great amount of interest. So at this moment, AWS continues to be really big, but I think very closely followed by Azure, and then Google Cloud certainly generating a lot of interest at this moment. I also believe that Google is putting a lot of focus on the cloud platform, where I think Microsoft has done a great job of reinventing itself around providing cloud technologies and showing that success out in the broader market. I think Google is taking a page from Microsoft's approach here as well.
Yeah. So so to make this work, how do I have to open? What's the impact of my on-premises security and technology? Do I have to open firewalls in the data center in order to use this? How does that get implemented?
Yeah, so that's a good question, right? So of course, how it gets implemented certainly depends on the kind of strategy that you use from a data integration perspective. If we focus on the data replication technology, right? So our space, we use a distributed architecture, and for our distributed architecture, there is a central component that we refer to as the hub, that is your single point of control, that is always going to introduce or start the replication, and it maintains the state, etc. Now, from that perspective, the hub needs to be able to reach the data endpoints. Now, some of our clients, or actually a significant number of our clients who do integration into the cloud, but do have on-premises systems, they choose to deploy that central component in the on-premises data center. The architecture from our perspective is modular and flexible, so customers could choose where they run it. They could even co-locate it with, let's say, a capture or an integration side. But customers with on-premises sources do often choose to put it in an on-premises data center, just because that means that they only need to open up the firewall into the cloud, and that's, of course, as we probably all know, or most of us will know, is only a few clicks away, and it's very easy to do. There's relatively limited negotiation needed with network administrators because they understand and trust this concept. Now, all of that said, we do more and more see organizations also adopting the cloud for the HR hub component as well. That's where the discussion of the proxy comes in that I had mentioned earlier, where there is the ability to avoid opening up the firewall directly into the data replication endpoint. Rather, you'd go through a proxy that acts both as the gateway as well as the gatekeeper at that point, right? So there is a configuration there that you can specify exactly what kind of connections are allowed, and technology will simply reject any connectivity that is that does not meet those criteria. So we see that a lot as well. So that in the end avoids, with at least with the use of the HR technology, it can completely avoid the need to open up the firewall into production database servers or database technologies altogether. Use an agent on premises, use a proxy, and then the hub can still be in the cloud. If the hub resides on premises, well, then there is absolutely no need whatsoever to open up a firewall into the on-premises data center. At that point, it can be just into the cloud, and that'll be sufficient.
Okay, perfect. The next question, I think it's related around data quality. I think it was consideration number 5. So how can you detect if it's in sync or not in sync, depending on your perspective, right? How is that validated? What are your recommendations for that?
Yeah, so that's an interesting question, right? Because of course, I think the level of trust will vary depending on how strict your data validation routine is. Some organizations will look at the data validation routine as to just comparing the number of rows in source and destination and decide if the number of rows matches. Well, then that should mean that the data is in sync, which I think provides limited perspective of what really the true data quality is, right? Because if I happen to have the same number of rows, that doesn't necessarily mean that I have the same rows. All it means is that I have the same number of rows. So from a data validation perspective, in the HR technology, we provide 2 options. One option is what we refer to as a bulk option. That bulk option will retrieve the data that's within the scope, and you can define filters, and you can do vertical projection, so you could eliminate columns to limit the scope. But then within that scope, we select all the data, and then we compute a checksum, and then validate if the checksum on the source and the destination matches, and if it does not match, then we will determine that the data is out of sync. And then as part of the report that we generate, we also provide the number of rows. But again, the number of rows is by no means the determining factor on whether the data is in sync or not. It's the actual checksum. And computing that checksum is actually quite a challenging component, because in a heterogeneous environment, we're dealing with differences in data types, and that is not to be underestimated. But that's one approach. Now, a second approach that we provide, or actually going back to the first approach that we refer to as bulk. So one of the key benefits of the bulk mode is that it can run in the distributed setup, right? We can have an agent compute the checksum, and it only needs to report the checksum. So that's very limited data transfer over the wire to compare that value to the value that was computed on the other side of the comparison. Now then there is a detailed, what we refer to as a row-wise comparison method as well, where in fact within the scope, every single value of every single row will be compared, right? So again, the scope can be limited using a filter, using column projection, but then every single value will be compared, and then out of that we can generate the exact detailed list of differences and indicate what the actual state is, and we could tell you exactly these are the rows that are out of sync and these are the values that are different. We provide this in a live mode, so we'll take into consideration that data can be moving, and we will validate that in a live system we will do an actual true validation of the compare result in such a scenario. But that's how we compare, right? So again, I think data validation goes well beyond just looking at, well, how many rows do we have on source and target. In fact, customers may do things like soft deletes, right? They may mark rows as deleted on the destination rather than physically deleting them. And some of those kinds of transformations are built into the HR technology. And if you do something like that, well, then it's to be expected that you end up with more rows on the destination than on the source.
Right.
So all of those considerations need to be taken into account as we validate and compare the data.
Yeah, validation is a big challenge, right?
Exactly. Yeah.
There's a lot to be considered in there, and and the larger the volume of data, the challenge I think increases, and then resyncing if something has to happen. One last question.
Exactly.
For you. Yeah, one last question for you is what is, and I know typical is always, I'm going to ask a typical kind of question, right? A question with the word typical in it. But I know you have there's a wide range of transactions and sources and destinations of the data. But what do you see as a kind of a typical latency for a real-time load that you guys work with?
Yeah, so that's a good question. So the question, it depends also somewhat on what the destination is, right, and what kind of use case we're dealing with. So I'll give you two answers, right? So the first answer is because like typical is hard to capture. So certainly we have organizations who use real-time replication technologies for more of a real-time, even for a high availability scenario. So in those kinds of systems, we see latency well below 10 seconds. And so well within 10 seconds after the transaction on the source was committed, it'll be committed on the destination. And very typically, the latency is under 2 seconds. So that's extremely low. Now, I had already mentioned earlier on that we see a lot of data lake use cases. We see a lot of data warehouse technologies. And in those kinds of cases, organizations end up using a technology that is not necessarily suitable for, let's say, a 2-second latency scenario, right? Like, let's say you take data out of your on-premises SQL server and you deliver it into ADLS. Like, would you really want a new file on ADLS for every table that changed every 2 seconds? I think the answer to that is if we take a reality check there, then the answer is probably no, we do not, right? Rather, maybe we're looking at one file per table that was changed every minute, right? And that's where the technology provides flexibility to introduce, let's say, a schedule on the delivery side when we do continuous capture, and the capture will be in about a second. Will the data have arrived to be ready to be delivered on to the destination? But then we deliberately pause from a delivery into the destination perspective because we don't want the data necessarily in real time. And that's where we look at, let's say, I would call it minutely kind of latencies into analytical environments. If you think about Synapse as a destination, then also naturally you would end up with more of a latency that's measured in minutes rather than seconds. And the reason for that is because Synapse was never designed to be as responsive from a real-time single row transaction perspective as a SQL Server was, right? So for Synapse, we build optimizations to make sure that we can maintain the aggregate volume of changes going into Synapse. And remember, like one source could be generating up to about 1 terabyte of changes in a single hour. We could have multiple sources all delivering into the same consolidated data warehouse or data lake, and we need to maintain the throughput in order to get the data into those systems. So in those kinds of scenarios, again, it's unrealistic, and well, whether technology-wise it would be achievable or not, I think is is besides the point, because it becomes cost prohibitive. It's just unrealistic, I think, to expect that to be latency measured in seconds. Rather, it becomes minutes, right? And then maybe you end up seeing that in a scenario like that, with very many or with multiple very busy systems and potentially very many sources feeding into the same system, we end up with latencies that are typically more in the 5 to 15 minute range, right? So that is more realistic. So again, there's lots of dependencies, as you rightfully pointed out, Mike, but I think certainly yes. And as a last question, I think it's a great question to end with. Like, in the end, it all varies. How much are you investing in these technologies, and what are the business requirements? I think that's what you always want to go back to when you consider, like, okay, what latency should we strive for, and what does that mean from a deployment infrastructure perspective?
Right, and that's why I think this particular presentation today is absolutely important to consider if you're doing this stuff, right? I mean, these are all the key components. If you get these right, then your implementation is going to be better. Focusing on one and neglecting another will always kind of produces some sort of a lopsided result, right? So this way here helps give a smooth, streamlined kind of presentation. But thank you, Mark, for the great data and information, stuff that we can all work with. As we all are marching more and more towards the cloud, these are all great considerations, how to get stuff from on-prem into cloud and to keep them in sync. Thank you again, Mark. I appreciate that. We appreciate you guys being providing support, and we appreciate your continued support to the virtual chapter. Thank you, everyone, and we'll see you in 2 weeks.
Thank you. Goodbye.